Okay, so now we will finally move on to point slope form. And just like the name suggests, now instead of having a slope and an intercept in your line, you are going to have a point and a slope in your line. This is what your equation should look like. Y minus y1 equals m times x minus x1. Okay, so this is the next formula that you're going to have memorized. So y equals mx plus b, and then you do have to have this one memorized. So remember, I said these equations are always going to have a place for your input and an output. So in this particular case, your m is still going to be a slope, but this x and this y always are just going to stay in that equation. These two are going to make up your point. So this is obviously the x value of your point, and your y1 is obviously going to be the y value in your point. Okay, so over here, this is what your point is, and we're going to be talking about this a little bit. Your point over here, when you're taking it out, is always going to be x1, y1. Your formula is telling you have to subtract in order for this to actually work out, just like your slope formula is m equals y minus or y2 minus y1, x2 minus x1. That's just how the formula works. So whenever you take out your point from here, it's always going to kind of look opposite of what the actual number looks like over here. So if I was like subtracting 2 over here, I would actually be pulling out a positive 2, and you're going to see what I mean a little bit more once we actually get going. And then obviously your slope is still going to be m. Your slope is always m. So for part F over here, when we actually start doing these equations, say I give you the point 1, negative 2, and then I want your slope to be negative 3/4. All right, so remember, we're always just plugging it into that original formula over there. So we have y, this y always gets to stay. Oops, hold on. That would help. We are going to have y minus y1. Sometimes it helps to just label your points just so you don't get confused because your x value is coming first. So we do need to subtract, and now we have a negative 2. You need both of those negative signs in there because that does make a difference. And then equals my slope, which is negative 3/4, and then x minus my x1, which is just positive 1. Okay, but I don't like having double signs in my equations. So you guys have to remember that whenever you're subtracting a negative, you change both of them and it becomes addition. So now I have y plus 2 equals negative 3/4 times x minus 1. So this is kind of what I was saying before. Your point and what it looks like inside of your equation over here, it's always going to look like the point and the equation have opposite signs, okay? So I'm going to just put a little note over here for you guys to remember. So point is opposite signs when in the equation. Okay, so notice over here, my x looked like it was positive 1 in my equation. It looks like it's a negative 1. My y in the point was a negative 2, and now once I put it into my equation, since I was subtracting, it turns into a positive 2. So eventually, you guys can just kind of skip this step, and then you can go straight to this step. So if you know you're subtracting a negative, you can just write it in as a positive. Okay, now since we have that, let's go on to actually graphing something like this. So our first equation is going to look like y minus 3 equals 1/2 x plus 1. So just like with the other, with slope-intercept form, we always need to start with a point. All right, so step number 1 is start at the point. Now remember, your point you are pulling out of these guys. These guys represent your point, but there's a couple of things that you have to watch out for. So make sure when you are pulling out your point, you always have x, y first. So always make sure your x value is going to be with the x's in here, your y value is going to be with the y's, but then they're always the opposite signs when they're in their equation. So when I start to pull out my x value, my x looks like it's a positive 1 over here. That means I had to subtract a negative 1 in my original equation to get that positive 1. So if it looks like a positive 1 in here, and my point is going to be a negative 1. Then to get my y, I'm looking over here. Since I'm subtracting 3, it looks like a negative 3, but I am subtracting a positive 3. So it always looks opposite in the equation than what it is here. So all you have to do is remember that put the x first, switch a sign, then put the y, switch a sign. Okay, so when we go to graph this over here, I am going to be starting at the point -1, 3. So -1, 3. Oops, I'm not leaving myself much room over here, but that's okay. All right, then once you have your starting point over here, then the second step still remains the same. You just apply your slope. And in this case, my slope is 1 over 2, and that still just means up 1 and right 2. So up 1 to the right 2, up 1 to the right 2. Oops. Yeah. Oops, it was supposed to be here. I lied. I was like, that doesn't look like a line. I should have paid a little bit more attention. And then we can also go down 1 to the left 2. Since we ran out of space going that way, we should probably just end up going this way. And then we can draw in our line. Whoa. Too many pens in my hand. Terrible line, but that's okay. You guys know what I mean. Okay, let's try one more of those. And again, you can feel free to pause it, graph your own line. Make sure your line's better than mine. All right. So for now, for this one, just trying it again, y plus 2 equals -2 times x minus 3. So over here, we still want to start at our point. And again, we want our x value first, and we always want the opposite of that. So it looks like a -3, so I want a positive 3 in here. And then we go to our y value. It looks like a positive 2, so I want a -2 in here. And that's where we are going to start graphing. Okay, so positive 3, -2 is over here. That's our starting point. And then 2, remember we are going to apply our slope. Our m in this case equals -2. And again, whenever we have a whole number, we always want to throw that 1 underneath it so it knows we're going to the right one. So now this means we are going down 2 and right 1. So now from this point, I'm going down 2 into the right 1. Automatically, I ran out of space. So that means I'm going to go up 2 to the left 1, up 2 to the left 1. And I usually just try to fill up the whole graph when I do these. So I just try to always go in both directions. Okay, so that is graphing in point slope form. But we do want to still talk about those special cases. And we kind of have talked about them already, but just in case you don't remember. So let's start at the top over here. I'm actually going to move my camera. Okay, so for the first one, and yes, these will be on your quizzes at some point or another because you really need to remember how these work. So I is going to just be x minus 3, and j is going to be, I'm sorry, x equals 3. I think they said x minus 3. J is y equals -2. Okay, so if you haven't already started shouting at your computer screen, hopefully you guys know what I'm talking about over here. Whenever you have an x equals equation or y equals equation, there should be 6 letters that automatically pop into your head, and they should be bucks and hoy. So bucks obviously has the X in there, so that is going to go with this one. And then hoy has the Y in there. That means it's going with this one. So whenever you just have one variable equal one number, it's vux hoy. You just have to match it up. So for this one, this means I have a vertical line with undefined slope, and it's going to be an x equals equation, or it's going to be going through my x-axis. You can look at it 2 different ways. So for this one, all I have to do is go to x equals 3 on my x-axis and draw a vertical line through it. Just like that, that one is done. Hoy means the opposite. Now I have a horizontal line, which has a 0 slope, and now it's going to go through the y-axis, or it's a y equals equation. The other way you can think about this is, if since you have a 0 slope, it's kind of like having y equals 0x minus 2. So it's another way you can think about it. But pretty much if you go to -2 on the y-axis, and now all of your lines are going to have -2 as their y values. Every single point on this line will have a y value of -2. Or you can think about it as you're going up 0 into the right one, up 0 into the right one. So whichever way you want to think about it, but just make sure you guys know those. And then really fast, I'm going to sneak this stuff in here. So parallel lines. Parallel lines have the same slope, but they have different y-intercepts. Okay, and again, this is, you can use this symbol for parallel. It's just 2 lines that look like they're parallel to each other. And again, if you want a, just an example of this. So if I have y equals 2x plus 1, and I graphed another line, y equals 2x minus 3, they have the same exact slope, but different y-intercepts. That means that these guys are never going to cross. And I'm going to put that down over here, never cross. Okay, so those are parallel lines. Then the next one, perpendicular lines. And we'll practice these in class. So perpendicular lines, and you always have to remember both of these words. They have opposite, reciprocal slopes that must be both. It cannot be one or the other. Okay. Perpendicular has like an upside down T as their sign. So every now and then I'll be using that. And then if you want examples of perpendicular lines, so if you say, let's say we have the same exact first line, y equals 2x plus 1. And it doesn't matter if their y-intercepts are the same or different for perpendicular lines, but their slopes must be opposite reciprocals. And what I'm talking about with opposite, I'm talking about signs, opposite signs. So that means I want a negative slope for this one. And then if this slope is 2 over 1, the reciprocal obviously means flip the numerator and denominator. So opposite reciprocal means I would have a -1/2 slope, and then it doesn't really even matter what the b is for that one. And then for these ones, they cross at a 90-degree angle, because that is what perpendicular means. So perpendicular lines cross at a 90-degree angle. They have opposite reciprocal slopes. Okay, so let's just practice these really fast. And for this one, okay, this one's the easiest one that everybody gets wrong. Okay, if you remember your vux hoy and all of that stuff over here, so this one's vux and this one's hoy, you have a vertical and a horizontal line over here. Vertical and horizontal lines are always going to be perpendicular. That's just their nature. That's the only answer that you can have for that one. If you have a vertical and horizontal line, they automatically have to be perpendicular to each other. Conversely, if you have x equals 4 and x equals -2, both of these are bugs. Both of these are vertical lines. One's going to go through +4 on the x-axis, one's going to go through -2 on the x-axis. These guys must be parallel. Two vertical lines must be parallel. They're never going to cross ever, ever. But let's actually make it a little bit more challenging for the last one. So I'm going to give you two lines. So y equals 6x minus 2. And hold on, I have 12x, sorry, I started writing that wrong. 12x minus 3y equals -5. Now, this one is already in slope-intercept form. I need to compare slopes to see if they're parallel, perpendicular, or neither. Okay, so over here, I need to get this one into slope-intercept form. So remember, this one is where we get the x's on the right side of the equal sign. So we're subtracting that 12x. Then we have -3y over here after these guys cancel. I want my x's first, so minus 12x minus 5. And then I have to get this y all by itself over here, so I'm going to divide everything by -3. And that means I have y equals -12 divided by -3 is +4x. And then -5 divided by 3 is still going to be a fraction, but a negative divided by a negative is going to be positive. So this is going to be +5 over 3. And again, all I need to compare are the slopes. So since this one has a slope of 6 and this one has a slope of 4, oops, sorry, meant to put that down. That means that they are not the same. They are not opposite reciprocals of each other. So these are neither. And that just means that they are going to be some sort of intersecting lines. They're just going to cross at some point, but they're not going to necessarily cross at a 90-degree angle. Okay, that one was a long one, so thank you for playing along. I'll see you guys in the afternoon.